So today we're going to see how to do the differentiation of functions to the power of n. So x to the power of n. You should already know how to that a function that the derivative you can write it in two ways, like this or like this. So let's say we have a function, an easy one, x squared. How do we do the derivative of that function? F prime would be, the rule is you get, if you have fx equals x to the power of n, f prime equals n times x to the power of n minus 1. So if we do x squared, f prime would be 2, we put the n downwards, times x to the power of 2 minus 1 equals 2x. Okay? So if we have another example, for example, gx equals 5x to the power of 7. G prime would be, if we use the formula, 5, remember, if we have a constant times a function, we can take the constant outside and do the derivative of the function. So we ignore the 5, leave it, multiply it, take down the 7, 8 to the power of x to the power of 7 minus 1. So that would be 35x to the power of 6. Okay? So that's easy. That's with all the powers you would do the same. How would you do it when n is not an integer? It's, for example, a negative. It can be if it's a negative integer, for example, or if it's a fraction. So imagine you have ix equals, let's make it easy, square root of x. So if you have, this works if you have square roots or any type of roots. Okay? So what you do is you just change that root into the same notation but with the powers. So that's x to the power of 1/2. And then you do the same formula. I prime of x would be 1/2 times x to the power of 1/2 minus 1, which is 1/2 times x. 1/2 minus 1 is minus 1/2, because if you have different signs in the numbers, you subtract and then you end up with the sign of the bigger one. So now that would be finished, but we have to leave it in the same notation that we were given. So we will say we will put 1/2 times, and then when you have a negative index, you put it in the denominator, and then we have 1/2 times square root of x. Okay? So let's do another type of root. You can have y equals 3 times, okay, we can do that. So y prime would be, the 3 stays the same. Before we do the differentiation, we will write the original function in powers instead of roots. So that's 3 times x to the power of 3/7. The index of the root goes in the denominator and the index of the function goes in the numerator. Okay? So now we do 3 times, this stays outside, this goes down, and that's 3/7 minus 1 again. So that will be 9/7 x to the power of 3/7 minus 7/7. We'll do it step by step. So 9/7, remember always, you can do as many steps as you want. That's, if you subtract, that's the 4, and the sign is minus. So now let's put it back as we were given it. So that's 1 x to the power of 4/7. And then if we put it back, then again, we have 1 to the power of, that's it, it's multiplied. Okay? So that's with roots in the numerator. If we have this type of functions, fx equals 1 divided by, for example, we'll do the same thing. Just transform that into the alternate notation where you have x to the power of 2/5, and then we will have prime equals 2/5 x 2/5 minus 1. So that's 2/5 x to the power of 2/5 minus 5/5, 2/5 times x to the power of 3/5 with a minus, and then we put it back, so that will be 1 x to the power of 3/5, and the last step, 1 x to the power of 5/3. So that is how that would end. Okay, so it doesn't matter if the root is on the numerator or denominator, or if you have a x to the power of something. They're all done with this formula, and they're all done the same, except that roots you have to change them up a bit. You can also do that formula, of course, for any function where the power is, again, down there. So you just write it like that, and then do 3, h prime is 3 times minus 7 here, x to the power is minus 7 minus 1, minus 21 x to the power of minus 8, minus 21, minus 8 goes down, that's 8.